Welcome. We are going to discuss about binomial expansions by starting with the definition of a binomial expression, then discussing about Pascal's triangle and stating the general binomial theorem for expanding expressions of the form x plus y power n. So binomial expressions are of the form So expressions of the form x plus y, where x and y are distinct terms, are called binomial expressions. So for example, x plus y, a plus b, c plus d, 1 plus 2x, 3 plus 4y, a half x plus 3y, etc. are all examples of binomial expressions. So simply, if we have expression which involves summation of two terms, it's called a binomial expression. The expansion of binomial expression is what is called binomial expansion. So we begin by discussing binomial expansions, where n is a positive integer. So an activity binomial expansion of expression of the form a plus b power n when n is 1, 2, 3, 4. So the first case, when you say a plus b, we get a plus b. So this ab power 1 gives us just a plus b. Then a plus b power 2, when you expand this, you get a squared plus 2ab plus b squared. Then a plus b power 3 is the same as a plus b times a plus b squared, which is a squared plus 2ab plus b squared, which will be a cubed. A by 2ab will be 2a squared b plus ab squared plus a squared b. B by 2ab will be 2ab squared, then plus b power 3, which will be the same as a cubed plus, so this term and this term are like, so it will be 3a squared b. This term and this term are like, so I'll have 3 ab squared, then plus b cubed. Then a plus b power 4 will be given by a plus b times a plus b power 3, which is the same as a plus b, and a plus b power 3 is a cubed plus 3a squared b plus 3ab squared plus b power 3. So this will give us a into a cubed plus 3a squared b plus 3ab squared plus b cubed plus b into a cubed plus 3a squared b plus 3ab squared plus b cubed. So when you expand, you get a power 4 plus 3a power 3b plus 3a squared b squared plus a b cubed plus a cubed b plus 3a squared b squared plus 3ab power 3 plus b power 4. So putting together like terms, so we'll have a power 4. Now this term and this term are like, so we'll have 4a cubed b. This term and this term are like, so there'll be 6 of them, 6a squared b squared, plus this term and this term are like, so 4a b power 3, then plus b power 4. So we note something about these 4 expansions. So we are saying that if we have n, if n is 1, the coefficients in the expansion of a plus b are, in fact, when n is 0, we have just 1. So a plus b power 0 is just 1. When n is 1, we got a plus b power 1 was a plus b. So coefficient here is 1, here is 1. So you have 1 and then 1. When n is 2, we found out that we had a plus b power 3 is the same as power 2, the same as a squared plus 2ab plus b squared. So here coefficient is 1, this is 2, this is 1. So you have 1, 2, and then 1. When n is 3, we found out that the expansion of a plus b raised power 3 was a cubed plus 3a squared b, then plus 3ab squared plus b cubed, b cubed. So a plus b cubed was a cubed plus 3a squared b plus 3ab squared, then plus b cubed. So coefficient 1, 3, 3, 1. 1, 3, 3, 1. When n is 4, the terms were, so a plus b power 4, we had a power 4 plus 4a power 3b plus 6a squared b squared plus 4ab cubed plus b power 4. And coefficients we have 1, 4, 6, 4, and then 1. There's a pattern here. You see, this when n is 0, we have 1. Then when n is 1, coefficients are 1, 1. Then when n is 2, coefficients are 1, 2, 1. So you see, each of the extreme ends coefficients are 1. And to get these two, we are simply adding this one and this one. Now, when n is 3, we have 1, 3, 3, 1. You see the extreme end, we have 1, 1. Then to get these 3, we are just adding the previous coefficients when n is 2. So 1 plus 2 is 3. 2 plus 1 is 3. And then the extreme one becomes 1. Similarly, for n equals to 4, 1 is the extreme. Then this next coefficient will be the sum of 1 plus 3. 3 plus 3 is 6. And then 3 plus 1 is 4. Then the nth one is 1. Similarly, we can predict how coefficients will be when n is 5. So the extreme will be 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Then the end is 1. Similarly, when n is 6, we can predict it. So extreme will be 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 15 is 20. 5 plus 1 is 6. And then we have 1. So you see there's a pattern here, which looks like a triangle. So these coefficients are defining a diagram which looks like a triangle. And this triangle is what we call the Pascal's triangle. So there's a fashion of a triangle for these coefficients. And this is what is so called the Pascal's triangle. So we now formally state the binomial theorem when n or the power is an integer. So we say, so theorem, binomial theorem, let me call it theorem 1, for positive integer index of power. So this theorem states that for any two numbers, x and y, if n is a positive integer, then x plus y power n is given by summation n, or we say r from 0 to n combination r, x power n minus r, then y raised power r, which can be written as when r is 0, we have n combination 0, x power n, plus when r is 1, n combination 1, x power n minus 1, y, r is 2, n combination 2, x power n minus 2, y power 2, plus r3, x power n minus 3, y power 3, plus other several terms up to n combination n of y power n, where n combination r means n factorial over r factorial into n minus r factorial. So that's what we call the binomial theorem for positive power n. So note that when we say n factorial, we mean n times n minus 1 times n minus 2 all the way times 3 times 2 times 1, where by convention, 0 equals to 1. 0 factorial equals to 1. So for example, 0 factorial is 1 by definition. 1 factorial means 1. 2 factorial means 2 times 2, 2 times 1, which is 2. And then 3 factorial is the same as 3 times 2 times 1, which is 6. And then 4 factorial means 4 times 3 times 2 times 1. 4 by 6 is 24. 5 factorial means 5 times 4 times 3 times 2 times 1, which is the same as 120. So we can clearly see that you can write higher factorials in terms of lower factorials. For example, 5 factorial is the same as 5 times. Now, if you pick this from here, this is the same as 4 factorial. Similarly, we can say same 5 factorial can be written in terms of 3 factorial if I pick from here and say 5 times 4 times 3 factorial. Similarly, I can write that 5 factorial as 5 times 4 times 3 times, if I pick from here, then this will be 2 factorial. So the concept of writing higher factorials in terms of lower factorials can help you to simplify some problems. So for example, simplify 7 factorial over 5 factorial. This will mean you write 7 factorial in terms of 5 factorial and then cancel out the 5 factorials from the expression. So this means 7 times 6 times 5 factorial over 5 factorial. So this is 1, this 1. So this is 42. And then if you are given 10 factorial over 8 factorial, you simplify this one as 10 by 9 by 8 factorial divided by 8 factorial. So this and this cancels out. So this gives us 90. Then if you are given C, say 100 factorial divided by 97 factorial is the same as 100 times 99 times 98 times 97 factorial divided by 97 factorial, then multiply this. So you can easily work out 100 times 99 times 98 to be the solution. If we have 1000 factorial divided by 998 factorial, if you key this one into your calculator, you get a math error. But then the concept of reducing higher factorials in terms of lower factorials helps you to get the exact answer. So this will be 1000 times 999 times 998 factorial divided by 998 factorial. So this is 1, this 1. So this is 999,000. Then another example, if you are given 10 combination 1 means 10 factorial over 1 factorial into 10 minus 1 factorial. So it should be 10 factorial over 1 factorial times 9 factorial, which gives us 10 times 9 factorial over 1 times 9 factorial. So 1, this will be 1. So the answer becomes 10. If you're asked 10 combination 5, we'll have 10 factorial over 5 factorial into 10 minus 5 factorial minus 5 factorial. Which now reduces to 10 factorial divided by 5 factorial times 5 factorial, which is 10 by 9 by 8 by 7 by 6 by 5 factorial divided 5 factorial times 5 factorial. So this one. So it'll be 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1, 2, 1, 2, 3, 3, 1, 3, 1, 4, 1 into 8, 2, 5, 1, this one is 2. So we have 2 by 9 by 2 by 7, and this is the same as 18, this is the same as 14. So 18 by 14. So we have 2, 5, 2. We have 252. If you are given 6 combination 4, we have 6 factorial over 4 factorial into 6 minus 4 factorial, which will be 6 factorial over 4 factorial times 2 factorial, which is 6 by 5 by 4 factorial over 4 factorial times 2. So this one, 1, 3. So the answer will be 15. If you're asked to define 7 combination 3, it will be 7 factorial over 3 factorial into 7 minus 3 factorial, which will be 7 factorial over 3 factorial times 4 factorial. So 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial, 1, 1, 1, 3, 1, 1. So this will be 35. So that is how we define binomials when n is positive integer. And this is the way we calculate combinations. So note that the general term in a binomial expansion is given by T r plus 1, which is given by n combination r, a raised to power n minus r, b power r. So let's do an example. Expand x plus y power 4 by binomial theorem. So this will say x plus y power 4 equals to summation r from 0, n is 4, then 4 combination r, x power 4 minus r, y power r, which means x plus y power 4 would be the same as 4 combination 0, x power 4 plus 4 combination 1, x power 3y plus 4 combination 2, x power 2y squared plus 4 combination 3, x power 3y, x power 4 minus 3, which will be 1. So the power of x will be 1. But the power of y will be 3, then plus 4 combination 4, y power 4. So 4 combination 0 means 4 factorial over 0 factorial into 4 minus 0 factorial, which will be 4 factorial over 0 factorial times 4 factorial. This one, 0 factorial is 1. So 1 by 1, 1. 1 over 1 is 1. So here we'll have just x power 4 plus 4 combination 1 means 4 factorial over 1 factorial into 4 minus 1 factorial. So be 4 factorial over 1 factorial times 3 factorial, which is 4 times 3 factorial over 3 factorial. So the answer will be 4x cubed y plus 4 combination 2. 4 combination 2 means 4 factorial over 2 factorial, 4 minus 2 factorial, which will be 4 factorial over 2 times 2 factorial, which is 4 times 3 times 2 factorial over 2 times 2 factorial. So this and this cancels out, 1, 2. So 6x squared y squared plus 4 combination 3 means 4 factorial over 3 factorial, 4 minus 3 factorial. So 4 times 3 factorial over 3 factorial times 1 factorial. So the answer just be 4. And then 4 combination 4 means 4 factorial over 4 factorial, 4 minus 4 factorial. So you have 4 factorial, 0 factorial, which is 1. So just y power 4. So those will be the terms of that expansion. So this is the answer to x plus y power 4. Next, we have expand x plus 2y power 6. So here, this will be the same as summation r from 0 to 6, 6 combination r, x power 6 minus r, 2y power 6, these two are 2y power r. So which will be 6 combination 0, x power 6 plus 6 combination 1, x power 5, 2y power 1, plus 6 combination 2, x power 4, 2y power 2, plus 6 combination 3, x power 3, 2y power 3, plus 6 combination 4, x power 2, 2y power 4, plus 6 combination 5, x, then 2y power 5. Lastly, plus 6, combination 6. Then x power 0, just 1. So 2y power 6. Now, this will give us 6 combination 0 is 1. So just have x power 6. 6 combination 1, we get 6. And then x power 5 times 2y. 6 combination 2 is 15. X power 4 times 2 power 2 times y. 6 combination 3 is 20. And then we have x power 3 times 2 power 3 times y power 3. 6 combination 4 is 15. X power 2, y power 4, 2 power 4, y power 4. 6 combination 5 is 6, x, and then 2 power 5, y power 5. And lastly, 6 combination 6 is 1, 2 power 6 times y power 6. Now, when you multiply, we get x power 6 plus 6 by 2 is 12. So 12 x power 5 y. 15 by 2 squared is 60. X power 4 y power y, just y power y power 2. Remember here is 2 because 2y was raised power 2. So the 2 affects 2 and 2y at the same time. Plus 20 times 2 power 3 gives you 160. X power 3, y power 3. 15 by 2 power 4 is 240. X squared, y power 4. 6 by 2 power 5 gives us 192. X, y power 5. 2 power 6 is 64. Y power 6. And then use binomial expansion to expand x minus 3y power 5. So x minus 3y power 5 means 5 combination 0 of x power 5, 5 combination 1 of x power 4 minus 3y power 1. So because this one can be written as x plus minus 3y raised power 5. So this is our A and this is our B. So then plus 5 combination 2, x power 3 minus 3y power 2 plus 5 combination 3, x power 2 minus 3y power 3, 5 combination 4, x minus 3y power 4, and lastly 5 combination 5 minus 3y power 5, because x power 0 is just 1. So 5 combination 0 is 1. So I'll have just x power 5. 5 combination 1 is 5. So 5x power 4 times minus 3y. And then 5 combination 2 is 10. X power 3 times minus 3 squared times y squared. 5 combination 3 is also 10. Then x squared times minus 3 power 3 times y power 3. 5 combination 4 is 5, x, then minus 3 power 4, y power 4, and then 5 combination 5 is 1, which will be now negative 3 power 5 times y power 5. I remember when you have a negative number, you raise to an even power, you get a positive sign. When you raise to an odd power, you get a negative sign. So this will be x power 5 minus 3 times 5 is minus 15, x power 4, y. Minus 3 is raised power 2, which is an even power, so the sign will be plus. So 3 squared is 9 times 10 is 90. Then this negative 3 is raised power 3, which is an odd number, so we have a negative sign. 3 cubed is 81. 3 cubed is 27 times 10, 270. Then minus 3 raised power 4 will give us a positive sign because it's an even number. So plus 3 power 4 times 5 gives us 4, 5. X, y power 4. Minus 3 is raised power an odd power, so the sign will be minus. Then we get 243 y power 5.